Okay, let us see the example when the car is moving around, around a bent track. So we say there are two cases: when we have a maximum speed, when we have a minimum speed, and when we have a moderate speed. Those cases are different. Now here, you note that this one is going to be of maximum speed. The question will state it and you'll see. So a car of mass 500 kilograms moves with a constant speed, v meters per second, round a bent track. Around the bend, the track is bent at 45 degrees to the horizontal and the car moves in a circular path of radius 20 meters. If the coefficient of friction between the road and our car is 0.5, and the tires of the car can't slip sideways on the track if moving at maximum speed of v meters per second. I think we see that now maximum speed. Whenever we have maximum speed, then friction is going to act downwards. Find the reaction between the car and the track. B, frictional force. B, maximum V, and hence the angular speed. So starting with the simple sketch there. So in our solution, this is going to be the first case. This is the horizontal, and then this is going to be the bent track. As simple as that. So this one, I'm telling you, is at 45 degrees to the horizontal. Of course, this is a car. Its weight is, its mass is 500 kilograms. Of course, because of the weight, we are going to be having what we call the weight because of that mass. So it's going to be weights. Because there is contact between the surface and the car, we are going to be having a reaction there, R, and then because it's maximum velocity, we are going to be having a force that's going to act in that order. Okay, now from there, they are telling us that this one is moving in a circular path. Of course, as it's moving around it like this, it's going to be making a circular path of radius. They are telling us this radius is 20 meters. So this is our center. You know, as it's moving in this is the idea we have. So as it's moving like this, it's making this radius there R. So there, most of the things I think are done. So now our task is to resolve this and this. So this is the F, the frictional force in that order. Why is it at maximum speed? Because when it's moving there, friction is, it can't slip even downwards. So meaning friction is going to act that side. Okay, now in that case, now we start to resolve this. Now you note that if I'm to bring for you this diagram, I think you can see the idea we are having. We are having this, and then we are having this as 45. Remember, we have also that. So if this is 45, it means that this one is going to be 45. This angle is always equal to that angle, and so this one is also going to be 45. Because this is always 90 minus the angle there. So if I'm based now on R, now start this force here is going to be having at an angle of 45. So if we base on R, that R of ours, so this is the case we are going to be having. I'm going to be having it in this format. So this is the case I'm having for my R, and this angle here is going to be 45 degrees. So now if you solve this, it's going to be the horizontal is going to be F. This is adjacent, so cos 45, and then the vertical is going to be in this order. So it's going to be R. Sorry, this is R, R. Then this is sine 45 degrees. Now, if I come to the force, this force here, this is the force we are having there. By the angle here, I think you can say this angle for it is going to be 45. This is the force here. So this angle here is going to be 45 degrees. So now, if you resolve it, also, you see this is adjacent. So this is the adjacent arm, so this is going to be F cos 45. Then this is going to be the opposite, which is going downwards because our force is coming this side. So we are going to go like this, then we come to it. So going downwards is going to be the opposite, which we can ably do it in this format. So this is going to be F sine 45 degrees. So after doing that, there is a very easy. Start by resolving vertically upwards. If we resolve vertically upwards, we have this, and this is opposite. So we have R sine 45 degrees, then minus F sine 45 degrees. This one, sine 45 degrees, equaling to, you see now this is the only force acting downwards, which is 500 G. And now from here they wanted us to get just the reaction of the tap. Okay, so you know what G is, I know what, by the way, force 45 is. But I know that the frictional force, not that our frictional force is always equal to mu r. And in the question, they gave us mu as 0.5. So meaning an hour, this is going to be 0.5 r. Because they gave us mu. Here in our solution, when we say that our mu was given at 0.5. So which we have there. So basically, so it depends where you put this angle. So if you put it here, it's going to be, as long as you know how to those forces. Now, you see, and you know that always sine 45 degrees is equal to cos 45 degrees, which is equal to 1 over root 2. These are special angles. So we have here now r times 1 over root 2, then minus our f, which is now 0.5 r, then times 1 over root 2 is going to be equal to 500 times 9.8. And so if I simplify here, this minus this, I'm going to be getting 0.5 r now over root 2 equaling 2. And simplify, I think we get 4,000. Yeah, 4,900. And you can able to see that our r is going to be 4900 times root 2 over 0.5. So my r, the reaction, is going to be 9800 root 2 newtons. And that's going to be my reaction. So this is my part A. Now I want to get the frictional force. From here, and that always part B, our frictional force is always going to be 0.5 r. So this one is going to be 0.5 times 9800 root 2. Okay, so this is going to give me 4900 root 2 newtons with ease. So you see that we have everything there. Now they want us to get the velocity. So whenever they ask you to get the velocity, you always resolve horizontally. So let us resolve in this direction. Resolve in that direction. We have this and we have this. I think you can see. We have this, then we also have this going in that direction. So from there, we shall have r cos 45, then plus r, sorry, f not r, and this f going in this direction, f cos 45 equaling 2. Now we say all horizontal forces should be equaling to the centripetal force that is keeping that car in that horizontal circular path. So our centripetal is m v squared over r. which is equaling. Okay, we can leave it there. So we have this, we know this, we know this, we know this, we have this, we have that. So from here, our R is going to be 9, then times, this is 1 over root 2, then plus R F, 1900 root 2 times 1 over root 2, equaling to our mass, the mass of the car, which is 500 times the V we want over the radius of the car. I mean the radius of the circular path it's making from here up to here, which is 20. So I think we can see this one. Oh, sorry, this one we are missing the root 2, which you can ably put. So this 9, 800 root 2, it is also going to cancel. When we add this to this, we shall be having, so this is going to give us 14700 equaling 2. So this one is going to go, this will give us 25 V squared. And so our V is going to be now the square root of 14700 divided by 25. So my V here is going to be, so it's going to give me 24.2487 meters per second, and this is going to be the velocity at which that car, the maximum velocity at which that car is moving. Then, the next part, this is our part C. So they want us to get to the angular speed. You know that the relationship is going to always be, that this is equaling to root of 588. So, it's always equaling to radius times the angular velocity. So we have this, we have it there. Then we can get easily that is that our angular speed is going to be V over R. Our V is 24.2487 divided by 20. So now my angular velocity is going to be getting 1.2124 rad per second, and that's going to be our answer there. So that's how what happens when they want us to calculate the maximum speed. Whenever it's maximum speed and it's moving against this, or is this frictional force, it's going to be acting downwards like that. If it's minimum speed, then it's going to be acting upwards. The frictional force will be acting upwards. Why? Because if it's minimum speed, the car will tend as if it's sliding downwards. That's why friction is going to be acting upwards like that. So maximum F down, minimum F is up. Then you resolve. Resolving, these are the ideas you consider. You can even put this angle here. When you put this angle, then this one will be cos, then this will be, it's up to you. But me, in most cases, I want these horizontal angles there. So that's it. I wish you well.